Good morning, grade 6, and welcome to your Friday lesson of mathematics brought to you by WorksheetCloud. I hope you had a really good week. If you've been doing online or remote learning through school, I hope it's gone well. Just a reminder of the previous lessons that you can access on WorksheetCloud.com along with previous activities and memos. Make the most of those free resources that are out there. Okay, so just a reminder of the email address on your screen, grade6@worksheetcloud.com. Send me any questions. Today we are going to be looking at polygons. So yesterday we looked at angles, measuring angles, types of angles, and today we're going to stick with the geometry theme or shape and space theme, and we're going to look at some polygons or 2D shapes. And then on either side of that, you've got your warm-ups and your mental questions. I'm trying to make the mental questions a little bit more wordy for you. And I'm trying to challenge you a little bit more there. So hopefully you'll accept the challenge and knuckle down and give them some good thought. And then I've got your challenges and brain benders to finish off with. Okay, guys, so here is your warm-up activity for the day. Use your math skills to work out the value of each symbol and find the question mark at the end. Right, off you go. So well done if you worked out that puzzle. So the first thing we're looking at is the 380 divided by 5. And if you work 380 divided by 5, you should get an answer of 76. Okay. So if one of those guys is 76, then two of them are going to be 152. So we'll have 76 plus 152 plus 152. Well, you guys have got to admit that my my handwriting on Google Jam has improved a heck of a lot. Okay, then we go below that, and we know we're going to have to subtract 76. So what subtracts 76 gives me 68. So I can work that out by going 68 plus 76 gives me 144. And to get 144, I go 12 multiplied by 12. And then if I take off that 76 from 12 multiplied by 12, I get 68. Okay, then I can fill in the bottom. I know that there's 12 multiplied by something plus 76 is going to give me 316. So what plus 76 is 316, and that's going to be 240. So that person's supposed to be a hippie, and I think that's supposed to be because of the t-shirt they're wearing. Anyway, 12 multiplied by 20 is 240. 12 times 2 is 24, and then add the 0, it's 240. Add the 76 and you get 316. And then we know that these guys are 152 together. We know that the soldiers are 12. And we know that the hippie is 20. And if we go 12 multiplied by 20 first, because that's your order of operations, multiply before addition, and we add the 152, we get 392. Okay, so yeah, the numbers are getting bigger, which is great, and I hope you guys are managing to deal with that. Okay, guys, here are your mental maths questions for today. As you can see, they're quite wordy, so read the question carefully, make sure you understand what I'm looking for. Yeah, off you go. Okay, guys, so question number 1 says a car travels 40 kilometers in 30 minutes. How many kilometers will it travel at this speed in 3/4 of an hour? So if I've got 40 kilometers in 30 minutes, okay, and they want to know how many kilometers it will travel at this speed in 3/4 of an hour. The first thing I need to recognize is 3/4 of an hour equals 45 minutes. Okay, so I recognize that half of 30 minutes is 15 minutes. Okay, so therefore I must halve the 40 kilometers and it will travel 20 kilometers at that speed in 15 minutes. And then I need to multiply by 3 to get to 45 minutes. So I must multiply the distance by 3 and get to 60 kilometers. Okay, so 60 kilometers at that speed in 45 minutes. Okay, question 2, using money just to check how well you guys know your decimals. Okay, so find the change from 15 Rand after buying 2 kilograms of potatoes at 3 Rand 60 per half a kilogram. So 3 Rand 60 for half a kilogram, 7 Rand 20 for 1 kilogram, so 14 Rand 40 for 2 kilograms. Okay, and then I need to figure out the change. So 15 Rand minus 14 Rand 40, and you can see that that is 60 cents. You could have also written it as 0 Rand and 60 cents. Okay, right, then question 3 is a time question. So a bus departs at 19:47, which is 13 minutes until 8 o'clock in the evening. Okay, so we're in 24-hour time there. And it arrives at its destination 1 hour and 16 minutes later. What time? Write the time of its arrival. Okay, so here I'm not going to add 1 hour and 16 minutes to 1947 as a whole amount. I'm actually going to break it up. I'm first going to add the hour. So I know that's going to be 20:47, which is 47 minutes past 8 or 13 minutes to 9. Then I need to add the 16 minutes, and I know that it's 13 minutes until 9 o'clock. Okay. And I need to add another 3 minutes, so it's 21:03. Make sure you answer in 24-hour time because they asked you in 24-hour time. Okay, so just keep that in mind. Question 4 is a fractions question. So we're adding or subtracting fractions, and we can do that all in one go. It doesn't matter if there's a combination of subtraction and addition. My lowest common multiple there is going to be 40. 40, 2 goes into 40 20 times, so 20 times 1 is 20. 5 goes into 48 times, so 8 times 1 is 8. And then we're adding, 8 goes into 45 times, so 5 times 5 is 25. And then when you work that out, 20 minus 8 is 12, plus 25 is 37 over 40. And that's its simplest form. 37 is a prime number, so it cannot go any lower than that. Right, and then the last question, another decimal question for you. Okay, multiply the sum of 3,6 and 2,4 by 0,4. So, if you read that for the first time, it could be quite confusing. So just take it piece by piece. So first, multiply the sum of 3,6 and 2,4. So they're asking for an addition sum. So remember, the word sum is actually the answer to an addition question. Okay, so the sum of 3,6 and 2,4 is 6. All right, so that there is called the sum. And now they want us to multiply that by 0,4. And remember, you've got a couple options here. You can either go 6 multiplied by 4 is 24, and then divided by 10 is 2,4. Right, so we said that we would try and get rid of the decimal. So I've multiplied 0,4 by 10 to get 4, but then I must divide by 10 at the end. You could also say 6 over 1 times 2 over 5, and that's going to give you 12 over 5, and that's going to give you 2 2/5, and that is also 2,4. All right, so remember 2 over 5 can be converted to 4 over 10, and then that's 0,4. Okay, so guys, I hope you did all right with these mental questions. Let's move on to some polygons and see what today's lesson has in store for us. Okay, guys, so in polygons, we're going to be looking at triangles first. So just a quick recap, polygons are many-sided shape. Poly means many, gon sides, so that's where you get many sides. 2D shapes are two-dimensional, so we're looking at length and breadth or length and width. But let's have a look at triangles. So the first thing we're going to look at is labeling lines and labeling angles in a triangle. So how do we label the sides and how do we label the angles? So as you can see, it says when we label angles in a triangle, we use capital letters. And we know that the angles are at the corners, and the corners in maths are called vertices. So it's many corners are vertices. One corner is a vertex, and we either label it clockwise or anti-clockwise. All right. Okay, so there are my labels for my vertices, the capital letters. And then to label the sides of the triangle, we can use smaller letters. Okay, now the smaller a is always opposite the big A. So the side BC, which is labeled A, is opposite angle A. And you'll see the side AC, which is labeled small b, is opposite the capital B. And the same goes for side AB, which is opposite the capital C, that is labeled with a small c. Okay, that diagram probably makes a lot more sense than a verbal explanation. The triangle is called triangle ABC. Okay? Right, so I'm going to let you label those question marks quickly. See how you go, and then I'll give you the answer when we come back. Okay, so let's have a look at these answers. Okay, so that left-hand corner would have been R because it's opposite the side R, and we know that the vertices are capitals. The bottom side would have been a small p because it's opposite the angle of P at the top, and the bottom right angle would have been labeled Q because it's opposite side small q on the left. That triangle would be called PQR. Okay? Right, so that's labeling triangles, their angles, and their sides. So triangles are also named according to their properties. Okay, and again, just to recap for you, a right angled triangle contains a right angle, and that right angle is indicated by that small square. And in a previous lesson, we spoke about why that sign was a square, purely because every single vertice of a square has a right angle. Okay. The longest side is always opposite the right angle in a right angle triangle, and that is called a hypotenuse. And I believe in grade 8 or 9, you'll start looking at the hypotenuse in more depth when you start looking into Pythagoras' theorem. Okay, any triangle containing a 90-degree angle is a right angle triangle. Okay, so it doesn't matter if it's lying at an angle, or it doesn't matter if what side it's on. The right angle can be, as you can see in the bottom left corner, the top right corner. So that's a right angle triangle. And then an isosceles triangle, which we're going to get into just now, may also contain a right angle. Okay, so just quickly, an isosceles triangle is a triangle where two sides are equal, but we'll get into that shortly. So those are right-angled isosceles triangles. So then an isosceles triangle, again, two equal sides. So we indicate those two equal sides with those two small stripes that you've just seen appear. And we know that the base angles of the isosceles triangle are always equal. Okay, so that's an isosceles triangle, and then that triangle has one line of symmetry, which means we can fold it in half along that line, and the two halves will line up exactly on top of each other. Okay. Then we have an equilateral triangle, And an equilateral triangle is a triangle where all three sides are equal, which can be indicated by those three lines. Okay, and also in an equilateral triangle, all three angles are equal. And I'm hoping you guys remember that the angles in a triangle add up to 180. And I'll show you the proof for that shortly. So therefore, in an equilateral triangle, all three angles are equal to 60, because 60 plus 60 plus 60, or 60 times 3 is equal to 180. An equilateral triangle has three lines of symmetry. So if you fold that triangle along any of those lines, then the two halves are going to fold on top of each other perfectly. It also has a rotational symmetry of order 3, and we'll get into rotational symmetry and reflective symmetry in a few days' time. Right, a scalene triangle has no equal sides and no equal angles, so you won't see any lines being drawn on a scalene triangle because everything about that triangle is different. Okay, and it has no lines of symmetry. So what type of triangle would this be? Okay, you're quite correct. It's going to be an isosceles right-angled triangle or right-angled isosceles triangle. And what symmetry properties does it have? It has one line of symmetry. So if I fold that triangle along that dotted line, then both halves will line up on top of each other. Okay, this takes us on to angles in a triangle. So there you got three different types of triangle. You've got an equilateral triangle, okay, called equilateral. If you look at the first four letters of equilateral, it's E-Q-U-I, so equi. So that's the first, at least the first three letters of the word equal. So we know all the sides are equal and all the angles are equal as shown by the lines and the round circles. Okay, an isosceles triangle, it's got two equal sides and two equal angles, and the angles that are equal are at the base of the triangle or at the base of the two equal lines. Okay, and then a scalene triangle, three unequal sides and three unequal angles. And what's interesting or important to note here is that in a scalene triangle, one of the sides has got one stripe in it, then another side's got two opposite the yellow circle, and then opposite the blue circle, it's got three stripes. So because they're different number of stripes in each side, that shows us that each side is not equal, or each side is different in length. Okay, so those are your three types of triangles and their properties. And now the proof of why angles in a triangle add up to 180. So if we take three identical triangles as the one at the top, we can piece them together like so. All right. Now, if you have a look at that top triangle, you've got a red triangle, a blue square, and a yellow circle. And we know the angles in a triangle should add up to 180. In a previous lesson, we covered that angles on a straight line add up to 180. So you can see where I've pieced the three triangles together. I've made a straight line. Okay. And there's the pink semicircle, which is the same shape as a protractor to indicate the 180 degrees. You can also look at that pink semicircle as half a circle, and we know that in a full circle it's 360 degrees. So in half a circle it must be 180 degrees. So there you can see within that pink circle, it's got a blue square, a yellow circle, and a pink triangle, a red triangle. And each of the triangles have that, so therefore the angles in a triangle add up to 180 degrees. Okay, feel free to play this back and have a look at these visuals again if you need to go over it for a second or third time. And there's the underlying proof. Angles and angle sum of a triangle are equal to 180. Okay, so we're almost finishing off here. Why is it important to know the angles in a triangle add up to 180? So if I gave you this triangle and I said, listen guys, what is the size of angle A? you need to be able to go and figure it out, and you can figure that out by saying the angles in a triangle equal 180. So therefore angle A will be 180 minus 65 and 90, and I know I can get 65 degrees because it's there. I need to be able to recognize the right angle sine is equal to 90 degrees, and then it's just a case of subtracting 180 from 155 and I get 55 degrees. Okay? Example number 2, the sizes of the angles A, B, and C. So we know that that's an equilateral triangle, and we know that the angles in a triangle add up to 180. So we just say 180 divided by 3 is equal to 60. Okay? So I'd like you to tell me what are the sizes of angle A. Okay, so to work out the size of angle A or B, we know that that's an isosceles triangle indicated by the 2 stripes on either side of the triangle. So those 2 lines are equal, which means that angle A and the 65-degree angle are equal. Okay, so there's your reasoning. So if my base angles are 65 degrees each, I need to add them together, and that gives me 130, and then I subtract 130 from 180, and that tells me that my angle B is 50 degrees. Okay, and then your last example, go ahead and work that one out. Absolutely correct if you had recognized that that yellow triangle is an isosceles triangle, and that x and y are going to be equal. So I need to say 180 minus 130, which gives me 50, and I need to divide that 50 by 2, and that's going to give me an angle of 25 degrees. So angle X and angle Y are both 25 degrees. Okay, off you go and figure that one out. Is a triangle, and they've indicated a right angle in that triangle. All right, so I know that there are 180 degrees in a triangle. I must take off the 90. That means 90 degrees needs to be split between the isosceles triangles A and B. I know that A and B are equal, so 90 divided by 2 is 45. Right, there's your next example. Straight away you should be saying, oh, that's an isosceles triangle, because no sides are indicated as being equal. And hopefully by now you've realized that you need to add 15 and 27 together to get 42. Okay, and then I need to subtract that 42 from 180, and I get 138. So my size of angle A is 138. And guys, if you want to check, all you need to do is add 138, 27, and 15, and that should give you the sum of 180. Okay, so there was quite a lot of information being relayed there, quite a lot of theory and quite a lot of characteristics that you need to know before we can move forward and identify angles in triangles and other shapes when they're combined. But the idea is to give you guys some theory and some background before we delve into the more difficult problems of finding and identifying angles. Okay, here's your brain bender for today, and this is also your challenge. You need to work out the values of the symbols. It's a multiplication table. Off you go, and then come back and see how well you've done. And have a look how well you did. The first thing I'm going to look at is what multiplied by 9 gives me 54, and that's going to be 6. So I'm putting 6 there next to the 18. I know 6 times 3 gives me 18. Okay, I know 10 times 3 gives me 30. And I know that the motorcycle must be 15. Okay, I've also recognized that there's 2 motorcycles, so I can repeat the 15. All right. So I know that the aeroplane is 6 times 15, which is 90. Okay, there's also an aeroplane in the middle square, and if I work out 10 times 9, that's also going to give me 90. So we know we're correct there because those values need to be equal. All right. Now I'm going to go look at the bottom row, and I've got 15 times 9. So 15 times 9, 10 times 9 is 90, plus 4 times 9, sorry, plus 5 times 9 is 45, so that's 135. Okay, and then I've got 15 times 15, which is 15 squared. So again, 15 times 10 is 150, plus 15 times 5 is 75. So I put them together and I get 225. Okay, so well done if you work through that one. Okay, guys, so that's all we got for today. Please feel free to send me any questions. On Monday, we will continue to look at polygons and 2D shapes. And then next week, we'll start looking into angles and identifying angles as well. Have a great weekend. There's a week to go, apparently. So stay safe, stay positive, be grateful for what you've got. And yeah, look forward to seeing you guys next week. All the best.